All right. So in this video, I want to be showing you how to determine the work done when a force is inclined. First of all, we need to understand that the work done or work is the product of force and what and displacement. Many textbooks rendered it as distance. That is wrong. It's displacement. And work can only be done whenever the force displaces the body. If the body is not displaced in the direction of the force, then work is not said to be done, because if displacement is zero, force times zero will still give zero work. Though energy could be converted, but work has not been done. So work can only be done whenever the force, makes the body to move. So we want to look at when a force is inclined. So let's consider a situation whereby we have a body like this. Now this body has a rope attached to its tail, and this body is to be moved from, let's say, this point to this point. So this is the distance we want this particular body, to cover. So this is the displacement basically. Some textbook uses x, but I'm gonna be using s. So it represents the displacement. This is the force, and let's assume that the force is inclined at an angle theta, to the horizontal. How do we determine the force, the work done by this force in moving this body, right, of certain mass from the initial position to, let's say, this new position? So let me use a broken line, right, to represent the new position. The first thing we need to know is that we've been able to define that work is force times displacement. So the work done by this force is the product of the force. Now, the force in this case is the horizontal component of the force. How do I mean? If you are applying this force, you are moving this body is being moved from here to here. So it's moving in horizontal direction. So it is the horizontal component of this force that is moving this box. Assuming this force is applied to lift this box up, then we can consider the vertical component. But it wasn't lifted, it was only moving in the horizontal direction. So in that case, we say that the work done, here is the product of the force. Is the horizontal component of the force, right? The product of the horizontal component of the force times the displacement, right? Times the displacement. All right. So the first thing is, I can write this as that W is equal to what? F subscript X times S, where F subscript X here represent the horizontal component of the force. Now, how do we resolve the force? If you look at this force has component along this direction, which is the vertical component, or we can put it here. This is the vertical component of the force, which I can call F subscript Y. Why this side is the horizontal component of the force, and which I can call F subscript X. So we're only interested in F subscript X. So to get F subscript X, we are considering F subscript X and F. So if theta is the angle of inclination, which is our reference angle, and definitely this is 90 anyway. So this is what? This is opposite, this is adjacent, and this is hypotenuse. So if we are considering F subscript X, that will be what? F subscript X, which is the horizontal component of the force and the original force. And this will be what? Adjacent and hypotenuse. And adjacent over hypotenuse basically is cos. That is car. So car in this case is what? Cos theta, which is equal to what? Adjacent, which is what? F subscript X over hypotenuse, which is what? F. So if we cross multiply, then we are going to be having what? F subscript X is equal to what? F what? Cos theta. All right. So we can therefore say that the work done is equal to what? F what? Cos theta times the displacement, which is what? X. So we can still simplify this to give us what? Fs cos theta. So this is the work done when the body is inclined on a plane with an angle of inclination to the horizontal given. I want to believe this video has helped someone. Please kindly like, subscribe, and share, and see you in the next video. Thank you.